Okay. All right. I figured we would start with some questions on the hand calculations. So, also, check Canvas. If you don't have the announcements coming to your phone directly, check it, because if we get the email from the university saying we're going online only, distance, not coming to campus, I'll tell you the directions for how we're going to be doing that, which will be Zoom and postings on YouTube and one-on-one and maybe group with Zoom. So we will keep going because you guys need this information and you need this training, even if whatever happens. Okay, so assignment, what are we on? 12, homework 12. Oh, did you see I graded your homework, your exam too? Your grades are on, and I noticed when I was doing that all the other grades were hidden. So had you guys seen your exam 1 scores? Yes? They were hidden when I checked. Anyway, so your exam scores are unhidden. Homework 11 I've graded. So all of that, so that's graded. And I started going through the summaries, and I got about halfway down the list checking off all the summaries. And then I'll have to go and make sure all the homeworks get finished grading. So making good progress on that. Keep going. Good, good, good. It does feel good. Yes? Homework 11, your grade should be updated. We can look at that at the end of class, okay? Because I...
Well, so mine is saying this assignment is dropped and will not be considered in the total
Okay.
So I wonder if there's something.
Okay, so there were some things with the assignments. Number one, I changed it. I had it set up on Canvas that if it was even a minute late, you got like half credit, and if it was more than, I don't remember how much late, it gave you 0 credit. And I took that off so I can manually do deductions if appropriate for lateness, so it doesn't automatically do that. For the homeworks and the summaries, I think it drops your lowest 2. So that note that you're getting about that not being included, because it's currently one of your lowest 2.
It's dropping my exam too.
It should not be dropping the exam.
It's dropping my lowest of the 2 exams.
Yeah, it should not be doing that. No exam should be. So let's look at that.
Mine's doing both of those, but I'm pretty sure that the grade on the homework 11 that it's showing is like the auto-calculated grade.
Yeah, I overrode them.
That or I really didn't understand.
I overrode them. I thought the other night. I went through every question on everyone's assignment 11, every single question, and so stuff happens, but they should be. So let's see, summaries. Okay, the lowest 2 summaries should be dropped. 20% of your grade. Okay. Assignments, lowest 2 are dropped, yes. Exam. Yeah, that should not be, let me edit that. Should not drop an exam. Okay.
Why would you ignore the highest score? Just a side question. But why would Canvas have that function?
Because some people,
Highest scores?
you know,
Yeah, seriously. Anyone to get named.
yeah. Okay, there. It should not say any of your exams are being dropped. I'm not going to pull up the homework 11 stuff here because I don't want to put everyone's grades up there. But if your homework 11 is saying 40%, something is obviously wrong on my end. So I will deal with that. Okay. I thought I had it all fixed. My goodness.
Mine's fixed.
Yours is fixed. Okay.
That's fine too.
Okay. Someone's are fixed. Yeah. If it's 40%, that means you're not getting credit for turning in the R component and the written essays. Now, homework 12. If you've already gone all the way through homework 12, I suggest you go back through it. I went through last night, and in an effort to avoid the write-in questions as much as possible, I changed some of them to multiple choice wherever possible. Now, that being said, this is the turning point in the semester. It is really crucial that you guys not only can run the right analysis, but you can communicate the results. So number one, you really need to be able to understand the output you get out and be able to write it up, because that's what you're going to have to do. That's what we're preparing you to do. So there are parts of starting in homework 12 where you have to write an abbreviated results, methods and results paragraph, not pages, but like several sentences. So we're going to look at that today. That's why I want to pull up the assignment 12, and we'll start at the beginning, but I want to get into where we not only are using R, but we're writing up APA-style abbreviated methods and results sections of how you would write up running a one-way ANOVA. And I added some, not really hints, but kind of guidelines in the assignment to help facilitate that. Okay, so here we go. So this is the first, that's not the first one. Okay, so item number 1. Okay, so here's the first one on the homework. Let me open up the answer key so that I can cheat, right? Okay. That's okay. All right. So this first one, you have, the situation here is that you have 240 students in this large psychology class divided equally in between where they were sitting, in the front of the class, the middle of the classroom, the back of the classroom. If we have 240 students equally divided into 3 groups, what is the subgroup sample size? 80. Where does 80 come from? 240 divided by 3. So that each one of those 3 sections has an equal number because it says divided equally. Now, most of the ones you do by hand are nice numbers to make things not so horrendous, okay? So we're supposed to, rats. I want to reset student. There we go. Oh, there we go. I didn't want the answers. I typed all the answers in last night to the whole assignment to make sure it was going to be marked correctly. Because thank you for those of you that let me know when there's an error. Thank you. I appreciate the emails that say, hey, I think on this number the answer's wrong because I put in what I think is the right answer and it's not getting marked correctly. Because there was at least 2 errors on homework 12 that got fixed. Okay, so there are the little boxes with the formulas to help you get started. All right, so to calculate the F ratio, here's the formula for the F ratio. To do that, we need mean squared between and mean squared between and mean squared within. So to do this one, first we need to find the grand average. How can you find the grand average? Average the averages. The mean of the means is the grand mean. So you add up the 3 means and divide by 3. K is the number of groups, 3. So anyone get the grand average? 33.4. So to do the MS between, we need to take each of the groups, 3 groups averages, subtract the 33.4 to find the deviance, square those, add them up, divide by 2, and times by 80. Anyone get that one? Mean squared between groups 1493.6. Yeah. Again, up there it says for all your work, keep up to 4, at least 4 decimal places if they're not 0. Okay. So mean squared within group. How do we do that? take all of our standard deviations, square them to make them variances, add them up, and divide by 3. So you take your standard deviations, square each one of them, add them up, divide by 3. Anyone get a number for the mean squared within group? 150.5636. Yeah, because it repeats. Yeah. Okay. So then when we make our F ratio, we divide these two numbers. Degrees of freedom. The first boxes that we put here in the parentheses for F are the degrees of freedom. What's the first degree of freedom number? The numerator degree of freedom. 2. Denominator degrees of freedom. 240 minus 3, so it's 237. Did anyone get what the F is? 9.92. So are we good on that one? Maybe a little like aggravating to have to do so much arithmetic. Okay. So what does this next one say? Double the standard deviations. Now, when we double the standard deviations, is that going to change our degrees of freedom? No. When we make our F statistic, is that going to change the top number? Nope. Just the bottom number. What does the bottom number change to in the F statistic? The new bottom number. Anyone want to check their work? 602.253 repeating. Yep. So what happens to the F statistic when we double the standard deviation? When we double the standard deviation, this was one of the mistakes. This was typed wrong before. When we double the standard deviation, what happened to the F ratio? It becomes a fourth as big. It's like we divide it by 4. Because originally on the top part, our F was 9.92. On this one, F is 2.48. Yeah. If there's more, remember when we did the little app? When we made the groups more spread out, they looked more similar. They didn't look as different when we made them more spread. Good? Okay. How do you guys like this problem? Do you guys even read the problems, what they're about? About drugs, marijuana, Valium, alcohol. Aren't these fun problems? What do you think about these averages? Do your averages ever come out to be that in real data? No. Okay. Does anyone have any questions with how you do the calculations? Plug in the numbers in. Now, on this one, I will say that the critical F that you look up in the table was originally wrong. That's what some entered wrong here. This was the wrong number before. I fixed it now. When you look it up, I was off by a decimal place. Anyone want to go over the answers? What are the degrees of freedom here?
3.
Why 3?
4 groups.
4 groups. What's the second degree of freedom, the denominator degrees of freedom? 28, because it's total sample size minus 4. What does that F come out to be? 2.64? Yep. So when you look it up, what degrees of freedom are you going to look up in the table? The same degrees of freedom. Yeah. And when you look it up in the table, it comes out to be 2.95. The first time I typed it in, I hit 4. Okay. Okay, so This was supposed to be an essay box, but I changed it to a multiple choice to make it easier to grade. I want you to have more feedback, not less. Okay, so if we calculate the F to be 2.6, but the critical F is 2.95, do we reject the null or fail to reject the null? Fail to reject the null. Now, in generic terms, we say fail to reject the null hypothesis, but you never write that in your conclusion. Your conclusion should never say anything about null hypothesis. Your conclusion should talk about, in this case, mental math, arithmetic, doing math, and the drugs. You need to put it in context. If you don't have context, then it's like fail to reject that could be anything. See, there is no evidence that any of these drugs affect mental arithmetic differentially. And it's not that for sure none of the drugs make a difference, it's that there's no evidence that the drugs differentially affect mental math, mental arithmetic. So this first one is just check the right box. As we move on the assignment, you have to write that out yourself. Okay. So how many people were there per group here? Or total subjects? 32. What now the second part says, what if instead you had 64? What parts of the F statistic are going to change? Will the numerator degrees of freedom change? No, it's still 4 groups minus 1. Will the second degrees of freedom change? Yes. Instead of being, what was it before, 28, now it'll be 60. For our F statistic, what will change? The numerator, the top, or the denominator, the bottom? Just the top, the mean squared between groups. What does it turn into? What? 5 point, give me 2 decimal places. 28. Yep. So what happened when we doubled our sample size? What happened to our F value? Twice as big? Multiplied by 2? Yep. Okay. Now starting in this one, we're supposed to do this in R. Okay? So let us go to, I'm going to pull up the encyclopedia. Which volume of the encyclopedia do you think we're going to go? What color? Green. Anova. Okay. So in this volume, for your reference throughout, I'm going to be putting some more stuff in here. So there's 2 examples that I use throughout here. Eno's data set and the cancer data set. I probably should add some more data sets. But we've got a 1 sample t-test, independent samples t-test. We've done those 2. I need to put paired samples t-test in here, but I don't have it yet. Today we're going to do one-way ANOVA. I need to put 2-way ANOVA, and then there's repeated measures and mixed design ANOVA. This is like most of the rest of our class. So let's go to the one-way ANOVA tab, or entry. Okay. It's not showing the... One-way table. Okay. Let's go to the PowerPoint for Chapter 12. It'll have it in there. The package we're going to use to do ANOVA. So ANOVAs, which we're going to spend the whole class on, can be fit with a ton of different packages in R. There are probably 50 different packages in R you can use to run ANOVA. Now, I'll tell you, I used to teach this in SPSS. SPSS had one menu system for a one-way ANOVA, a different menu system in Windows to click through for a two-way ANOVA, a different one for the repeated measures, and then even a fourth one if you wanted to do a mixed design ANOVA. So in SPSS, you had to learn a whole different menu system for each kind of ANOVA. What do you guys think about that? A lot of the packages are the same way. You have to learn a different way to do it for each different kind of ANOVA. Instead, Tyson and I have selected the AFEX package, AFEX, to do ANOVAs in this class, not because it gets a different answer, but because it is consistent in how you type your stuff in. It's consistent for a one-way ANOVA, two-way ANOVA, repeated measures at ANOVA, mixed design ANOVA. We can use the same command, the same way of typing it for all of our ANOVAs. So, what do we got right here? First thing I've got up here is the Levine's test. We've done Levine's test before, right? Before we did a Levine's test when we only had 2 groups, right? Now we're doing Levine's test when we have more than 2 groups, like 3 or 4. But it works the same way. So we're going to have our data set. We pipe it in using the CAR, that's the Companion for Applied Regression package, Levine's test. Did we do this? No, we didn't do this. Didn't we do a Levine's test?
In a previous assignment,
We did in a t-test.
Yeah, I think we did. But this is the way, so Levine's test, you always put your outcome or continuous variable before the tilde wave and your categorical grouping variable after the tilde wave. It's important that you get that order right. Data equals dot, why the dot? That's where the data set flows in. And center equals mean. I don't know why that's not the default. But then you get output like this. So Levine's test is a F test, and it stacks the degrees of freedom. So for Levine's test, the F is 2, 12 for degrees of freedom. Tells you what the F value is, and then here's the P value. Now, what does this P value tell us? In this case, the P value is not significant. So what does that mean, that the Levine's test is not significant? That says there's no evidence of violations of homogeny of variance, equal variance. So this is telling us that the variances can be treated as if they are the same. So this passes, we can check off that assumption of homogeny of variance. Now, we've seen table 1 as well, haven't we? Yeah. So table 1, you take your data set, you group it by your categorical variable, and then you do table 1 of your continuous variable. It'll give you your means and standard deviations of your groups as well as their sample sizes. Now, are these standard deviations exactly the same? No, what are they? They're 0.8, 1.5, 1.6. Are the spreads exactly the same? No. But Levine's test is telling us we can proceed as if they're the same because they're similar enough for our needs. Okay? So Levine's test says the spreads are close enough to the same to go. Now we want to know, are the averages the same? Okay, here we go. This is the code to do, do I need to go into presentation mode? Okay, here is the code to actually do the ANOVA, okay? So we're going to start with our data set. I'm going to ignore this part right here, because what is this first part doing? It's just assigning the results to the name fit ANOVA. We could assign it to the name George if we wanted. So this is the name we're going to save our results to. So we're going to start with our data set, pipe it in, and this is the package, AFEX, Analysis of Factorial Experiments. That's just the package name. And then the function name is AOV, that's shortcut for ANOVA, _4. Anyone have any idea why the number 4? It is because, now in this AFEX package, there are different versions of ANOVA syntax you can use. We choose to teach this one, the AOV4 command, instead of the there's ANOVA easy, but it's not that it's easier, but it matches a package called the easy ANOVA package. This one, the syntax we use in here, matches the package LME4, which is the package we use for multi-level modeling. And again, I don't know why the number 4, probably because it was the 4th version, made it to be out. But so we're going to use the AOV_4 command out of the AFEX package. So after that, does this look familiar? Where have we seen this before? It's the same thing you use for Levine's, the formula. The name of the continuous variable that we're comparing, tilde wave, name of the grouping variable that tells us which group people are in. And this can have 2, 3, 4, 5, 12 groups. What's new here? This piece here. Now, this formula has this other layer of complexity. This complexity is what we use if we have repeated measurements. Today, have we learned about repeated measurements? No. Yet, no. So far, we only have talked about situations where each person has one time point. That's why the number 1 goes there, because right now we only have one time point per person. So that's the number 1. When we get to the point where we have repeated measurements on time, then that will put something different there. Right now it's just a placeholder number 1 to remind us we only have one observation per ID. So ID, this is a variable in your data set that's like your identifier. Sometimes it'll be ID number, sometimes it'll be, what is it in Eno's data set? What's it called? That column that has the subject number in it. Subnum, SUB_NUM, subnum. So this, where this word, the letters ID are, that's the name of a variable that has the indicator for each person. And data equals dot to pipe the data from before. So this syntax, not too scary, right? Especially when you can copy and paste. The new thing is our formula has this parentheses part with a 1 vertical bar. Now, where's the vertical bar on your keyboard? It's above the Enter key. And do you have to use Shift? Yeah, Shift, the thing above your Enter key. So 1 observation per person. So 1 vertical bar, variable name that tells us who's who. So that's what we do to do an ANOVA. This would be ANOVA comparing groups on an outcome variable where we have 1 observation per person. Okay? Now, will this code right here, if I run it, will it produce any output? Right now. Why not? What am I telling the computer to do? Take this data set, run an ANOVA, and save it. When you do stuff and save it, nothing is outputted. Now, there's a reason why we do this, because we want to use this model, this analysis, maybe in multiple different ways. ANOVA results in R with this AFEX package are not outputted very perfectly. And there are different ways to ask for the results. And we might want to do in the future post hoc testing. We might want to do things. So that's why we're saving it to a name so we can do another step. Okay. Okay. So here at the top I have that same syntax, and then what would happen if I ran just the name? This is the default output we're given. So here I've ran an ANOVA and saved it as fit_ANOVA. And if I run just the name fit_ANOVA that I saved it as, this is what the output will look like. So this is telling us we did an ANOVA. By default, it does type 3 tests. We're not going to get worried about that. That is a great default. 99.9% of the time, that's what you want. And it tells us what's our response that we're comparing the averages of. Here it was called outcome. Okay, that's nice that it tells us that. Now, we only have a one-way ANOVA here, and we're comparing groups. Now, what's the next thing that comes? What are these numbers right here? Degrees of freedom. Why is it 2 degrees of freedom? Because we had 3 groups. This was the music one. Remember, we had quiet, classical, and heavy rock. And then the second degrees of freedom are 12. This next number right here, they're not always lined up perfectly. It's because of the font. The next number, this 1.9, that's the MSE. That's the mean squared error. That is the mean squared MS within group. Usually we don't report it, but basically that's the pooled standard deviation. So that's why it's on here. That's that. Then the next number here, 6.98, that is our F value. Then we get some little stars in this case. What do 2 stars mean? P-value is less than 0.01. So that's the F value. It's kind of ugly looking because things aren't lined up. What comes after the F value? It says GES. Okay, let me tell you what this means. The GES is for generalized eta squared. This is our effect size. So what do we say the effect size is? So GES is the generalized eta squared. It's the Greek letter that's like an N with the curly tail. This is like an R squared. It goes between 0 and 1. So this is between 0 and 1. The closer to 1, the more the groups are different. The closer to 0, the more similar the groups are. So this is our effect size measure. This effect size is 0.54. Do we need a 0 in front of that decimal on the effect size? No, because it's always going to be less than 1 in the real world. It's always going to be point something. And then this last number, the 0.010, is our p-value. So if I was going to write this at the end of a sentence, I would write F, and then what would come after the parentheses? 2, comma, space 12 equals 6.98. Be careful. It's really easy to write down the number that's for mean squared error because they don't line up very pretty. And then we do comma. The p-value comes next. What's the p-value in this case? 0.10. And then the eta squared goes after that. 0.54. Okay? So we do the F with the degrees of freedom in the parentheses, then the p-value, and the effect size last. That's the order that you put them in. Now this is part of the output. This is the most important part of the output. When you ask for just the name, this is what you get. But sometimes we want more output or we want it in a different way. So you can ask for a different arrangement of the output, same numbers but some more, by doing after the name, doing $ANOVA, all in lowercase. Took me a while and I still get confused which one's which. But all lowercase with dollar, all ANOVA. When you do that, this is what the output looks like. Are they the same numbers? How are they the same? How are they different? There, we get more decimal places here. Is anything missing? MS is 1.9. Where's MS? It's not there. And the GES, the effect size, is it there? No. So sometimes you'll want to say just the name, especially if you want the effect size. But it'll only give you, usually the p-value is only given to 2 decimal places this way, which is, usually we want more. But so if you do it this, ask for the output with the $ANOVA, you'll get more decimal places on your p-value especially, but it doesn't give you your effect size in the MSE. Now, in your homework, you're asked to fill out an Anova table. Let's see. Oh, where did it go? Come on. Okay. Can I make this big? See if I write on this. Oh, go back. Okay, there we go. How did I get? Where I said pen. It won't let me have the pen now. Oh, okay. Okay. This is also another really great piece of little syntax that's really helpful when you're doing an ANOVA. A picture can be worth 1,000 words. It can really help digest your numbers and present your information. Here I'm taking the data set, I'm piping it into ggplot. In the aesthetics, I'm giving it two variables. You can say x equals and y equals, but it will put them in the alphabetical order. So the first variable, this is being put as the x-axis, and the second variable is being put as the y-axis. That should be outcome. And then if you add a layer, before we've done geom line and geom point, you can add this layer stat summary, and what it does is it puts a point at each of the averages and makes these lines that are the standard deviation. So this is a visual. So we had group A, B, and C. Group A's average is higher. B and C are very similar. So what if we find a significant difference? We have to explain it. If this was, the p-value was significant, how will we explain it? We would say, what was this? Words memorized were higher in the quiet music than they were in the either of the music conditions. So you need to say which one's higher, which one's lower. You can't just say they're different. So a picture can help with that. So again, ggplot, the x and the y-axis, stat summary can help make a quick picture. Okay. Effect size. Okay, so I told you effect size is eta squared. Now in R, it called it GES, generalized eta squared. In a one-way ANOVA, there is only one effect size, and it is the eta squared. That's right, got the dot right there. Okay. If it's just eta squared, why does R call it generalized eta squared? And the reason is because when we get into repeated measures and mixed design ANOVA, there are more than one kind of eta squared. There's a partial eta squared and a generalized eta squared, and there's a repeated measures eta squared. So even though it calls it generalized eta squared, it's just plain eta squared if you're doing a one-way ANOVA. How do we know this is a one-way ANOVA? We only have one grouping variable. We're grouping it by music, not like by music and gender. We only have one grouping variable, so that's why it's a one-way. So eta squared is the most commonly used effect size for ANOVA. However, this is the biased measure. It's really easy to calculate. It has a very simple formula, but it's not quite right. Omega squared, and it's this like almost looks like a W letter, Greek letter. This is a more accurate, unbiased measure of the effect size. And there's formulas for both in your book, and we'll use both of them. I'm going to show them to you on the formula sheet. They're both there. We should be using omega squared, but SPSS didn't put it in there years ago. So everyone did omega or eta squared because that's what SPSS calculated. So that's what everyone started publishing, so everyone got used to it. Because this formula is not as easy to do, and SPSS doesn't automatically do it, so it's not as widely used, even though it probably should be. Now, we've already seen in G-Power what effect size does it use? It uses Cohen's F. This is the only time I see Cohen's F used is for G-Power. You can also use the interclass correlation rho, but that's less, very, very few times have I ever seen that with ANOVA. The first two are on a scale of 0 to 1. Third one is 0 to 1. This Cohen's F is not necessarily, and that's why it's harder to like interpret. That's why people don't use it as much. But the people who made G-Power decided that's the one they were going to go with, for reasons I don't know. Okay, so the omega squared is the least biased, so it should be the one we're using, but people haven't because of the time it takes to calculate it and that the software doesn't automatically do it. So most of the time when you do an ANOVA, report the eta squared. And that's what the R that I'm showing you does. Okay. So here's the formula if you had to do it by hand. Eta squared. Where is it getting that eta squared? It's taking summa squared between divided by summa squared total. Also, if you have a paper that you're doing a meta, what if you're doing a lit review? Who's doing a lit review? Anyone? Anyone have to do a lit review? All of you are going to have to do a lit review as part of your dissertation or thesis. You all are going to have to look up articles. And how do you know which paper has the bigger effect? The effect size. But not everyone reports their effect size. Shame on them. So if they don't, you can calculate eta squared if they've reported the F, which they should, and the degrees of freedom, which they should. So this is mathematically going to give you the same number as if you did this. Most people report the F and the degrees of freedom, but we don't ever really in a paper write out the summa squared or the mean summa squared usually. Okay, so here's our cutoffs we generally use for our eta squared. How much do I love cutoffs like this? Not much, but we'll go with it. A small effect is 1 to 6%. That's generally thought of as small. A medium effect is about 6 to 14%, and large, about 0.14-ish. So what do you say about this effect? Huge, massive. So not only is it statistically significant, we're sure that's not just random chance, but it's big effect. Okay. Now, there is this adjusted eta squared, which is trying to fix the bias here. People have proposed, but this has never caught on, so I don't worry about it too much. Yeah, so you can compute those. Most of the time in real life, we just use the eta squared that's spit out of most softwares. Okay. So this is the problem we did before about the music and noise. We calculated these colorful numbers up here. Remember doing this last time? Wasn't that so fun? So to do the eta squared, if we're going to use the summa squared, we'd take the summa squared between divided by the summa squared total, which is between plus within. Boom. That's by hand. Here it is using the F statistic, 6.89, with degrees of freedom 2 and 12. What do you notice about the two formulas? Get the same thing, and R pooped it out for us too. Just 2 decimal places. Okay. So the way that you can language what the eta squared means, the eta squared is the percent, remember it's between 0 and 100%. It's the percent of variation, or variance, the percent of variation in the outcome continuous variable that is explained by the grouping variable. So in this one, we'd say the type of noise or music in the room is responsible for over half of the variation in the number of words memorized. Notice, have I just said groups and outcome? No, I've put the words what they mean. What are the groups? The groups tell us type of music. What is the outcome? Number of words memorized. You put it in context for the thing it is that you're studying. Am I stressing this enough? Not generic terms. What is it that this problem's about? So here, the type of music played in the room accounts for 54% of the variance or the variation in the words each person was able to memorize. Are there other things that affected how many words they memorized? A lot of other things, right? But the type of music, that's a pretty big component, over half. Okay. So I said omega squared is better. What do you think about that formula? Those formulas are bigger, they're harder to memorize, and software doesn't automatically do it. What do you notice about these cutoffs? They're the same. They're roughly the same. Because it's the same thing. It's just, it's more conservative, less biased than the omega squared. So it's really ought to be used, but people usually don't do it. Okay. Here's Cohen's F. What do you think about that formula? You love this formula-heavy book? Yeah. So it takes omega squared and tries to, like, change it a little bit. You can convert back and forth. If you have omega squared, you can make F. If you have F, you can make omega squared. It's just a mathematical formula. But again, the only time that I see that used in the real world is just for G power. So if you're going to go to G power, what do you do if you don't have omega squared? You can use your eta squared if you're in a pinch. Or plug in the numbers that you know. What's K? Number of groups. What's NJ? Number of participants in each group. What if they're not all the same? You need a bigger formula. You do the harmonic mean of the sample size. Anyway, and mean squared between, mean squared within. We have formulas for those. Okay. Okay, last formula. This is ICC. Now, there's a little tiny note here. How many different ways can you calculate ICC? There are at least six frequently used versions of ICC, which means intra-class correlation. This is the basic format. I don't see it used hardly at all. Just wanted to make you aware of it. Okay. Last thing before we get back into doing homework questions. How do you write these up? So when you go to write up your results on the homework, and guess what else you're going to have to write it up? On the exam. Why am I making you do it on the homework and the exam? Because that's what you're going to use. This is an abbreviated methods and results paragraph. This is the kind of thing I'm looking for. If I just want the results sentence, that's this. Notice what's at the end of the sentence. We got our F, our P, and one of the effect size. Here I threw in the omega to be fancy, but you could also put the eta squared, probably more likely. But if you want to write it all up, this is what you need. So what do you need to include in your write-up? Okay. You need to probably include descriptive statistics and sample sizes. What do we mean by descriptive statistics? Means and standard deviations of each group. Sample size. Do I have to say this first group was sample size 5, the second group was sample size 5, and the third group was sample size 5? Do I need to say it that way? Why not? You could say easier, 15 participants divided equally in 3 groups. Isn't that a lot shorter? Okay, I have to slog through reading this, try to make it at least somewhat legible for me, like somewhat flowy, not totally redundant. Who's going to be perfect at this the first time? Anyone feel like they're going to be perfect at this the first time? It's practice time. Practice time, okay? We're going to practice languaging this. So you need to get the descriptive statistics and the sample sizes in there. What is our factor, our grouping variable, and what are its levels? 4 groups were randomly assigned one of these 4 drugs. Alcohol, amphetamines, marijuana. 3 music conditions were randomized. Tell us what the groups are, and if you just look over the data, what does your eyeball say? What's your eyeball say? It looks like the quiet group had more words memorized than the other 2. So you've got to give us like the situation as far as what are the variables, what are the groups, what's going on. And you should also put what test you're using. A one-way ANOVA was used to do what? To test the hypothesis that the means of the 3 groups, boom, 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 were different following the experiment. Tell us what test you're doing. Be blatant. So reporting, you need your F with your degrees of freedom and what its value is. The P I don't know what that slash E is there for, is less than some number, and some measure of association or effect size. Power is optional to include. Only include stuff about the power if you actually did it. You don't need to include the MSE or the mean squared within in your write-up. You don't have to. Cohen suggests it, but most people don't. And discuss any follow-up tests if you did them, if they're needed, which is chapter 13. So we're not there yet. Yeah?
I just wonder, how can you express the eta square on the computer?
Oh, because you got to type this in on the keyboard, right? For our homework purposes, just do E2, and I'll know that means eta squared. How about that? Does that work? Or N2. And now what do you do if you're really writing a paper? You're probably writing it in what program? Word. If you go to Insert, Symbols, you can actually get the Greek eta and put the little power of 2 on it. But for typing in Canvas for the homework and the test, just use the closest regular letter. So just use N and put a 2 next to it. Don't worry about doing the power for me. Okay. We're almost done. Oh yeah, 2 more slides. 1 more slide after this, and then we'll go to the examples. Good. We're doing good. Okay. If we have 3 groups, why don't I just run t-tests? Why don't I do control versus quiet, or control versus classical and do a t-test, and classical versus heavy rock and do a t-test, and quiet versus heavy rock and do another t-test? Why don't I just run 3 t-tests?
Because when you accurately run t-test, error becomes bigger.
What kind of error gets increased? Which type was that? Not round-off error, it's type 1 error. When you run separate tests, you inflate your type 1 error rate. Because what if I have 5 groups? How many different ways can I pair them up? A lot. I'll just say that, okay? The more groups you have, the more different pairings there are. So to protect us against inflating our type 1 error rate, we're going to run the omnibus or the overall f-test first. If you only have 2 groups, do a t-test. But the bigger k gets, the more different pairings you have. And that's a factorial design. So that's what we mean by factorial. So we are in danger of increasing our type 1 error rate, our false positive rate, if we just do lots and lots and lots of pairwise t-test. That's what we're going to talk about in chapter 13. So just hold on to that idea in the back of your brain. Okay, G-power is the last thing. So let's see, in your homework, which one asks you to do power? It's not 3, 4, is it 5? Should we do this one together? Then we'll do some more R. Okay, oh. Would you like to see that? Did it just turn off? It was there a minute ago, wasn't it? There we go. Okay. This is number 5 on your homework. Okay? For using G-power. Approximately how many subjects per group? What are we solving for? N. Are needed in a 4-group experiment. What's 4? What letter? K. 4 group. If F is expected to be 0.2 and power must be at least 0.77 for an alpha equals 0.05 test. Let's go to G-power and see. G-power. Okay. Is this test family a t-test? No. What should we change it to? F-test. ANOVAs are F-tests. What statistical test are we going to be doing? There's a lot to choose from. A little easier to see. The second one, Fixed effects, omnibus. Remember, what does omnibus mean? Overall, one way. Yeah, we're just done one ways. Okay. What type of power? A priori, because that computes the required sample size. Awesome. Okay. First box. What F should we put in? 0.2. I hovered on there. It gives me some cutoffs. We're going to put it at 0.2, which is medium-ish. Alpha? 0.05. That's good. What about power? 0.77. Real life, you're never going to do 0.77. What are you going to usually do? 0.8. Okay. And number of groups. We better change 5 to 4. Okay. Okay. Sample size needed is 260. What if I put 260 here? That's wrong. If I type in 260, it's wrong. Why? 260 in G power tells you the total sample size. The homework asks you each group. So you need to divide that by 4, which would make it 65. Yeah. Yay! Isn't that nice being able to get some feedback? I am so excited about this idea to give you feedback without me having to do anything more. I mean, I did a lot to get it there, but okay. Think you can do the rest of those? Yeah. I have faith in you. Okay. Let's skip over to 7. I want to talk about this one. So this one's good old Enos data set, and we're comparing the 5 majors, their math quiz scores, and their stat quiz scores. So the first thing, anyone remember anything about math quiz and stat quiz? Math quiz is missing people. Okay, to get these averages, I'm asking you to put the averages, the means in this table to a single decimal place. To do that, we can use the table 1 command, but you need to make sure, I put this note here, you need to make sure to put na.rm equals false to not kick out those 15 people that were missing the math quiz, because they have a stat quiz. Okay, let's. Yeah, where did we go? What happened? There we go. Okay. So go to the downloads. Open our assignment. Okay. It's still not putting the header on there to knit it. I'm sorry. I can't try anymore. Okay. Oh. Did anyone get this? Yeah, this was put on the discussion board. What happened? No package ls means. We've never used the ls means package before. The ls means package is dead now. They're no longer updating it. It is obsolete. Instead, we use the em means package, so you can delete this line here. If you took the time to install it, nothing's going to go wrong, but you don't need it anymore. In fact, to do this assignment, you don't need any of those. You just need those 4. We need the tidyverse to get us the pipe and dplyr. We need read Excel to read in Enos data set. We need furniture to make our table 1, and we need affix to do the ANOVA. Okay. There's some data sets, some little toy data sets, so you don't have to type them in. Let's go down to Enos data set 2A. Okay. Did I not do reading in Enos data set? Oh, there it is. Yeah, I better read that in. Okay. So I wrote the chunk for you to do the table 1. So group by major and give us the average of math quiz and stat quiz. But look at those sample sizes. Add up those sample sizes. There's 5 of them. So the first one is 25. You guys see that? Should I make it bigger? Do they add up to 100? No. They do not. There. Can you see that better? Yeah, so this is where you need to do na.rm equals false.
So if I don't have the little run options,
Ah,
what happened?
what happened?
Because they were there before, now they're gone.
I will tell you what happened. I'm over here on question C 2A. 2A. Okay, if your little buttons here disappear, it's because somewhere along the way your triple ticks that pair up for your chunks, you either have, something's wrong. You don't have 3 ticks and 3 ticks going with each other. You might have a space before one, or one of your ticks got deleted or added. So what you need to do is scroll up to the last chunk, the last chunk you can find that had play buttons. There it is.
When I put the header in.
Okay, yay. Oh, so it could be the header that has the 3 dashes. You can't have a space between those, and they've got to be paired up. Yeah. Okay. Okay, sometimes on this one, I did output equals markdown. That just makes it so that it looks a little better on the screen sometimes. You can leave that out if you want. Output. Oh, it'll make it actually a table, like an APA-style table when you knit it. Okay, here we go. Now we've got all 100 in here. Okay, so for the homework, I just want you to enter these averages to 1 decimal place. Just type these in. If you look at math quiz, what do you notice about the averages of math quiz? What would be your eyeball take on those averages? The 5 majors in math quiz. There is a difference? Is it easy to eyeball it? Why is it hard to eyeball it? You got standard deviations, and how many numbers are in that table? A lot. If a table has too many numbers, it's hard for our eyeballs to translate that into our brain. What's a better way to kind of get a better idea of what's going on? Plot it. Now, at least on Windows, if your cursor is here, it won't let you scroll when it's in this output. If you have that problem, just move your cursor over here to the edge and it will let you scroll. It drives me crazy. So just move your cursor over to the edge and it'll let you scroll. Oh, look, I put in the code to make the 2 plots. Who loves you guys? Okay, now can you eyeball? What's going on with the 5 majors in math quiz? It's a little easier to interpret now. Yeah, what patterns are you seeing?
Economics is much higher.
Economics are killing it.
Biology major.
Biology's struggling. Yeah. So if you were going to write this up, we're going to do a one-way ANOVA was performed to see if the students in the 5 majors differed in terms of their average math quiz. To see if economic majors really did do substantially better than biology students. Those are the 2 extremes. Everybody else is falling somewhere in between, right? That's the pattern we see. What do you notice about those standard deviations? I guess they're standard errors. Notice right here it has this little, it's not a warning so much as it's just some information for your own good. It says we didn't say anything else in stat summary, so by default it's doing mean and standard error. What do you notice about these spreads? What would you say about those spreads? looks similar-ish. Okay, now let's do the same thing but for stat quiz. What pattern do you see with the averages on stat quiz? Same pattern. The economics majors are doing, it looks like, much better, and the biology students, the worst. Everyone else somewhere in between. What do you notice about the spreads in those scores?
Well, economics is a lot more different this one. There's not as much close spread.
Look how tight economics is than compared to maybe like sociology. So now there's a question, at least for me, are these spreads really the same? Are they the same enough for our purposes? How can we assess that? Levine's test. So now we are going to do Levine's test. Now what do we call this data set? Clean. How do we do Levine's test? Car, Levine, test. Which one are we supposed to do first? Let's do math quiz. Math quiz, tilde wave, the grouping major, capital F, data equals, dot, center equals, mean. What about homogeny of variance for the math quiz? No evidence of a violation. So this is good. We don't want violations. Okay, I'm going to skip the next chunk. Let's do the same thing for stat quiz. Now, again, R doesn't care if you have enters or extra spaces. That's preference. I'm going to copy this because we need to redo this, except for instead of math quiz, we need to do it for stat quiz. So I'm going to come down a little ways. Oh, wait. I got to come down a little further. There's Levine's test for stat quiz. I'm going to change that to stat quiz. Oh. That's bad? What is this telling us? The spreads in stat quiz are different between the majors. We could see that that might be the case on those plots. The plots helped us, like anticipate or be aware of it. What do you think? You should not really be using an ANOVA for stat quiz. Why? Because we violated the required assumption of homogeny of variance. Can we do the ANOVA? Sure. Should we take it seriously? Probably not. Okay. I think there was something about that on the homework, right? Here we go. Based on the HOV, homogeny of variance test, i.e. Levine's test, for which dependent variable should you consider performing an alternative to ANOVA? Stat quiz. Because it looks like stat quiz has a different amount of spread in different majors. Comprende? Good. Okay. Now look at we filled out the Levine's test for both of those. That's the prerequisite. You have to do Levine's test to see if ANOVA is even like a legit thing to do. Then you're going to do the ANOVAs. Now notice I put some stuff in red. After the ANOVA, I said you can leave the p-value to only 2 decimal places because that's what the output by default gives you. I didn't want to make you, hassle. But notice what I put in red after the effect size. Type the letters NA if it's not applicable. Okay? In this one, there was an effect, so we said how big it is. What if our p-value had been 0.573? What does that tell us? There's no effect. Should we tell what size the effect is if there's no effect? That one, not applicable. If our p-value is not significant, we do not need to give an effect size because we're saying there's no evidence of effect. So somebody asked me, I put this in. They even sent me a screenshot. It was great. It made it so easy for me to answer. Let's look at it. I really wanted to make sure to do this. So let's do the stat quiz one since we're down here. So how do we fit a one-way ANOVA? Eno, clean, that's our data set. What package? Affix. What command or function? OV4. The car matches the car package. The easy matches this easy package. But it's different if you have repeated measures or not, and that just gets confusing. And so we're doing stat quiz here is our continuous variable we're comparing the averages of. By, what's the grouping variable? Major F. And make sure you have to do plus, parentheses, one observation per subject number. Because if I look at my data set, subnum is like our ID variable, so that has to go in the parentheses, and we only have one observation per person. We're not doing any repeated measures. Now let's save it as a name. Does it matter what we... Okay, what should we name this one?
Actually, it told us to save it as AOV_stat quiz.
Oh, okay, AOV_stat quiz. That must have been up above. Now, it gave us a message in red. Is that bad? Well, let's read it. Contrasts set to countertot sum for the following variables, major F. That is totally fine. We'll learn what that means next chapter, so you can ignore it, okay? That's something you don't need to worry about. Okay. So now we just put the name. Whatever we save it as up here, if we run just the name, we'll get that basic ANOVA results. So let's see, how would we write that one? F for 95 equals 2.05, comma, P equals 0.09, and I told you just to keep the 2 decimal places. That's enough here. Now, what about the eta squared? It's not applicable to put an eta squared because we're saying there is no evidence that the stat quiz scores are different by major. But should we even rely on those results? No, because Levine's test showed evidence of violating the base assumption of homogeny of variance.
So I have a
Yeah.
question on these. This one didn't ask for it, but some of them asked for us to fill out the Anova table.
Yes.
I'm a little confused what some of those boxes are. With
Yes.
those 2 different tables. Can we go through?
Yes. We are out of time, officially. So you are welcome to hightail it out of here, especially if you have something else going on. But if you want to stay for bonus time, I will keep recording and keep talking. Totally up to you. Nothing personal. Okay. It's a long day. Okay. I've gone back to our class page. I'm going to pull up this formula sheet. Okay. It's the 3rd page. This is what we mean by an Anova table. And notice I've organized all the formulas out of this whole chapter here for you. So this is a generic table for a one-way ANOVA. We have between groups is the first line. That's whatever our grouping variable is, and K is our number of groups. The second line is our residual or our error line, and the third bottom line is the total. Now, what do you notice about this grid? Each line is shorter than the one before it. That's how an ANOVA table is built. What do you notice over here? What are these formulas? That's our eta squared. That's our effect size. I threw the modified or adjusted eta squared, and there's your omega squared. Okay? So you don't have to memorize those. These are all the formulas that were presented through the chapter that you use. Okay. So for a one-way ANOVA table, the degrees of freedom, these are the numbers you need to fill out. Now, if we look at the output, I'm going to write on this. I am going to do the $ANOVA version of the table. Oh, it's a capital A. The slide was wrong. It's a capital A. Okay. Yeah, don't let me stress you out. Okay, I'm going to write on this with my pen. Okay. Okay. Yellow. Okay. Here we go. First thing, when you look at this output, remember this output has the $ANOVA with a capital A at the end of it. Always, always, always we ignore this intercept line. Always ignore. The line that says intercept, always ignore. Okay? The rest of this is our table. Except for it doesn't have the total line on there. You see how that looks like that table? Okay, so this first, what do we have? Sum of squared. There's those numbers. The second column is what? Degrees of freedom. What is it missing?
MS.
It's missing MS. It's missing in the R output. Then we have our F. And what's this last one? P. Now what it's missing is what should be this third line down here. This is our grouping variable, major F. Then this second line is error or residual. And what's this last line supposed to be? Total. Okay.
And total is literally just totaling.
Total is literally totaling it up. So how do we get this number right here?
It's
It's
pretty much every question.
It's on every question after the next two after this one.
This one you don't have to fill out the table
Yeah.
for, but every other question.
Yeah. So how do I get that bright green box? How would I get that? 22.8 plus 263.3. That's how I get this number. How would I get this blue box that I'm coloring right now? Four plus 95. So that would be 99. Let's see. And this one would be what? Let's see. What would that be? Oh, I got to do some math in my head. There. I added it up. Okay. Now, what is missing here? The column that's missing. That should be right here. This is the MS column. It's missing on this output. For whatever reason, I don't know how to make it give it to you by default, so you have to calculate it by hand. Here's, you ready for this? Or what?
You can just do the fit ANOVA.
The fit ANOVA, oh, it'll only give you the MSE. Which one of these, how many? Let's see, it should only be 2 of these. There should only be 2 boxes here. 1, 2. Which one of these is MSE? This one right here. Come on. Oh. There we go. This one right here, that one is the MSE. And you could get it off the other output, but there's an easy way to calculate it. Let's see, what's another color? Pink. If you take 22.8, divide it by 4, that's the mean squared between groups. If you do 263.3 divided by 95, that will give you your MSE. Either for either of these lines, if you take the summa squared divided by degrees of freedom, that gives you the mean summa squared.
I don't see where these tables are.
Go
I'm
to
on question 3, and it has it.
oh yeah, question 3. Yeah,
This one?
not this one. Go to the next one.
Like the next item.
Like 8. Go down. Is it 8? No, it must be before that. 4.
Question 3 for sure has it. 'Cause I just
There.
Oh, okay. I was like, I have not seen this where
Okay.
at in the data set. But.
Yeah.
They changed yesterday.
It changed last night.
Yeah.
Yeah.
It just showed up.
Yeah. I'm sorry.
So then to find eta squared from that,
Eta. What's the formula for eta squared?
the sum of squares effect over sum of squares total, so that would be the top divided by the total.
Yeah. So eta squared is the summa squared between groups over the summa squared within groups. So it's, if you were going to calculate it by hand, for this one it would be 22.8 over 263.3. Within groups.
So on the formula equation, it says SS total at the bottom number.
SS total.
That's what it says on the.
Yeah.
Yeah,
That's what-
SS total. There we go.
So it'd be the 286.
Yeah. Okay. Okay. So let's see. The first 2 columns add up going down. Those are the only 2 that total up. So that's why on the total line, there's only 2 boxes, because those are the only 2 columns that add up. To get the mean summa squared, we take the summa squared divided by its matching degrees of freedom. And then how do we make an F value? Mean squared divided by mean squared. Okay.
I think there's a wrong answer on 3.
On 3,
Which is 12.4. Because I calculate the eta squared and it has the right answer, but then it says how strong of an effect is this, and it's 0.29, so I put strong.
0.29 is strong. That's right. It should be strong. It should be strong. Okay, I'll fix that one. Okay. All right. So I'm going to get a whiteboard here. Coming? Okay. So if I had an ANOVA table, let me draw one. The columns go summa squared, degrees of freedom, mean summa squared, F, P. And it's between your grouping variable, and then it's residual or error. And then it's total. That's the format of a one-way ANOVA table. Okay, let me put some numbers in, because this could happen on your test, right? Could you finish filling out this table? Yes. Let's do it. Let's start with this first box. 400. Okay, let's go across the row. Ugh, that keeps moving. The next box. 200. Okay, we got to stop. Let's see. Error. What would this box be? 35. Oh, it's not so nice. Okay, I'm going to change this. There. That's nicer numbers, right? So what's this number? 4. So what's the F statistic? You take this 200 and divide it by 4. Because remember, the formula for F was mean squared between groups over mean squared within groups, or mean squared error. So that would be 50. Guess what the p-value is going to be? Anyone? Very small. Good job. Okay, last thing. What's going to be our eta squared on this problem? What's the formula for eta squared? You don't have it memorized yet? Sum of squared groups between groups over SS total. So that would be 400 over 500. That would be 0.8. So it's statistically significant. Yes, the groups are different, and it is a big difference. How many groups are there? This is a bonus question. 3 groups is right. How do you know there's 3 groups? Because that would be k minus 1. What's the total sample size? Oh. 28. So the first 2 columns total up. Sum of squareds total up. Degrees of freedom total up. And then sum of squared divided by degrees of freedom give you mean sum of squared. Mean sum of squareds divided give you your F, which you can look up. If it's bigger than 10-ish, it's probably significant. It depends on your degrees of freedom. And the effect size would be sum of squared group divided by sum of squared total. Did it get marked wrong?
No, I just saw a problem that
I probably added it.
something else you got added after episode.
That's why I asked you to please scan it. I was going to send an email saying every single thing I changed. I didn't make you do more work other than to fill in those tables. And the reason I want you to do the tables is because it helps you understand the relationship between all these formulas that are just overwhelming at this point. And guess what? We're going to add more and more each chapter. So I want you to understand how those values interact with each other more than the actual formulas. So so how would you write the conclusion here? The average of at least one of these 3 groups is substantially different than at least one of the others. I can't put it into more context because I just made that up. I don't know what the groups are or what the outcome is. Okay, I'm going to stop the recording and let you guys know that at the first of class, when are we coming back? Theoretically, at least, we'll see, right? Monday, whether we're in person or not, we'll start off by reviewing. I want you guys to be prepared to read out loud the results methods sections that you're asked to write in the last couple problems on the homework, and we can practice languaging them, because it's kind of awkward at first what you need to say and what order and what you cannot say. So we'll do that so that everyone can get 100% on the assignment. That's the whole goal. We want everyone to be able to do this without too much stress.